This is ThreeTopo, a mobile navigation app for rock climbers. Our research explores new interactions for wayfinding in complex, hazardous environments through the concrete case of multi-pitch trad climbing. But what is multi-pitch trad climbing? A multi-pitch is a rock climb that's too long to be done in a single rope length, so it's broken up into multiple pitches, where each pitch has an anchor that marks where it ends. Pitches are first climbed by the leader, who is in charge of finding the way to the anchor. Once they get there, they secure themselves and belay the follower. That brings us to the second part. Trad, or traditional climbing, is when the leader has to place removable protection in the rock as they climb, which should catch them in case they fall. The gear that they place eventually gets removed by the follower when they second that pitch. Alright, moving on. As part of this research, we collaborated with 7 expert rock climbers over a 3-month period to derive a set of design principles for navigation tools that support pre-climb planning and on-the-wall decision-making. These principles informed the design of ThreeTopo, which we built using iterative prototyping with input from our expert collaborators. This culminated in a 3-week public deployment of ThreeTopo where we collected feedback from 16 climbers in the Eastern Canadian Rockies. So, what did we learn? Well, our first principle is that a route's representation should be inherently precise. Current navigation resources come in 3 modalities: hand-drawn topos, written text descriptions, and annotated photos. Now, the problem with these resources is that they're compressed and ambiguous. They give you the general idea, but they leave critical details for you to figure out on the wall. As one of our experts described, current navigation resources are actually 95% accurate, they just aren't precise. To address this, ThreeTopo uses high-fidelity 3D models as the primary canvas, letting climbers see the complex rock features rather than infer them. These models were generated using aerial photogrammetry. A drone collected 795 still images, which were used to create a dense point cloud and a high-resolution mesh. This mesh was way too big to run on mobile devices, so we compressed it by baking the texture in normal maps onto the model and then decimating the geometry. This brought the model size from about 3 GB down to 170 MB without a noticeable loss in visual fidelity. Number 2. Information should be multimodal. Climbers don't just rely on one kind of information. They combine text, photos, and sketches to prepare. ThreeTopo brings these together into spatially anchored annotations that live directly on the 3D model, so descriptions, photos, and hazard warnings are always in context. Number 3. The system should support an embodied understanding. Climbing is not just about where, but also about how. Climbers frequently use visualization and mental rehearsal to prepare for the pitch they're about to climb. This helps them understand how they might execute certain moves, but also where they might need to worry about the gear they place to minimize rope drag while still protecting a fall. ThreeTopo includes human-scale avatars that communicate the size of features and illustrates crux moves and key positions, supporting climbers in building a complete and embodied understanding of how to get through a pitch. The last principle is that the cognitive and interactive load should be adaptable. Climbers prepare at home, on the approach, and at anchors just before leading a pitch. In each of these moments, they're attempting to build a situation model, a mental map of the terrain, so they can lead the pitch without active navigation assistance. Sometimes, though, that mental model isn't strong enough, and climbers have to reference the route description even while on lead, where they have extremely limited physical and mental bandwidth. To accommodate this, we designed one-touch interactions that allow for rapid navigation in the app. For example, a user can double tap then swipe vertically to move the camera forwards and backwards, or they can swipe horizontally to orbit the camera around the central point. The route slider lets the user quickly scrub through a predefined track based on the route path, while also indicating how far along the route they are in terms of elevation gain and total length. The active pitch button acts as a fast reference to the multimodal data for the pitch that they're currently looking at, so they don't need to navigate through a menu or find the anchor's spatial annotation. These interactions allow for detailed study before the climb and rapid one-handed lookups on the wall. While previous work in HCI has focused on the needs of novice climbers in more controlled settings, ThreeTopo demonstrates the integration of computing into a complex, high-risk climbing discipline. Ultimately, this line of research might lead to new tools that can facilitate more engaged experiences with our environments, aid learning, and improve safety, both in the context of climbing and beyond.